Today, I'm demoing Blindside, a private prediction market terminal built on Monad testnet. Before the product itself, the motivation is important. A professional trader may need to protect an active strategy, a founder or executive may need to avoid signaling, a treasury manager may need to keep risk exposure private, and any high visibility operator may need to avoid leaking every move on a public ledger. The core idea is simple. We want the speed of on-chain trading without forcing the user's primary public wallet to be the wallet that visibly interacts with the market. The flow starts with a normal MetaMask wallet. That is a familiar wallet the user already has, and in our product it acts as a public funding entry point, not the trading identity. From there, Unlink is the privacy vault. In this codebase, the user funds an Unlink vault from MetaMask first. That's stronger than treating privacy as a simple pass-through layer. A pass-through layer can still leave a clearer visual connection between the input wallet and the output wallet. A vault model is better because the value enters one private store first, then funds can be withdrawn out to the execution wallet separately, which does more to hide the direct relationship between where funds came from and where they end up being used. So the purpose of Unlink is not just in the middle, it acts as a vault that breaks the obvious on-chain linkage between the public MetaMask wallet and the identity decoupled public-facing wallet we use in the app. The user's main wallet is still how value enters the system, but it's not the wallet that has to become the visual trading identity. Once funds are in that private layer, the app can move out into the in-app execution wallet, and that is where Privy comes in. In the front end, Privy is configured as an embedded wallet on Monad testnet, so users can connect and trade without being kicked out into a slower execution flow every time they want to act. The purpose of Privy is responsiveness. It gives the product an embedded wallet that feels native to the interface, which means placing trades, checking balances, and managing positions can all happen inside one tight loop. That embedded experience matters even more because of the chain underneath it. Monad is what makes the trading loop feel immediate. This repo is wired directly to Monad testnet, and the value proposition here is the chain's very fast block times, roughly 400 milliseconds. The purpose of Monad is to make the market feel more real-time. Faster inclusion means lower slippage, a smaller window to get exposed in the mempool, a lower chance of getting front run, and noticeably more responsive experience when the user places or resolves trades. Then, we use Pyth in two distinct ways. First, Pyth acts as a live data API. The backend builds the price board by pulling live and recent price history for assets like Bitcoin, Ethereum, Solana, and XRP. And the front end uses that to render the live market view and chart. The purpose of Pyth here is to power the interface with current pricing, so users can see the market move in real time before they place an order. Second, Pyth is used as a settlement oracle. In this project, Pyth is not just display data. The deployment flow fetches the timed price at the start of the hour to set the market strike price. And when the hour ends, the resolver fetches another Pyth update to determine the settle price. The smart contract then resolves the market from that oracle update. So the purpose of Pyth here is to be the trusted source for both the setting and the strike and settling the outcome. So the full stack works like this. MetaMask is a public funding source. Unlink separates identity and capital flow. Privy gives us an embedded execution wallet. Monad gives us speed. And Pyth gives us both live market data and a credible oracle for resolution. That combination is what makes Blindside interesting. Private by design, fast enough to feel usable, and anchored to an external price source for market integrity.